All right, today we're going to build your very first programming toolkit. We're going to break down the core concepts you need to tell a computer exactly what to do, and we'll be using one of the most popular languages out there to do it, Python. So let's jump right in.
I mean, really think about it. Programming isn't some kind of magic. It's just a set of really, really precise instructions. It's the difference between asking a friend to grab that thing over there and telling a robot to pick up the red ball located at coordinates X and Y. We're learning how to give those perfect instructions, and that's the real power we're unlocking today.
So here's our game plan, our builder's journey. We're going to start with the absolute basics, the atoms of code. Then we'll see how to store our data and how to tell the computer what to do next. After that, we'll get into the rules of math, how our program can talk and listen, and finally, how to bring it all together to turn a simple idea into a working algorithm.
Okay, first things first. Before you can build anything, you've got to understand your raw materials, right? In programming, our raw materials, the stuff we're building with, well, that's data. So the smallest, most fundamental thing you can work with is what we call a value. It's just a single piece of information. Could be the number 42, the letter A, or even your name. These are the little Lego bricks we're going to use to build everything else.
Now, when it comes to numbers, Python kind of sees two main flavors. First, you've got integers, or ints for short. These are your classic whole numbers, no fractions, no decimals. Then you have floats, and these are any numbers that do have a decimal point. And this is a really important distinction because the computer actually handles them a bit differently behind the scenes. And what about words or sentences? For anything that's text, we use something called a string. It's easy. Just wrap whatever you want in either single or double quotes, and boom, Python knows you're dealing with text, not a number or some secret command.
Great, so we have our data values. But, having all these numbers and words just floating around in space isn't going to help us much. We need a way to store them and label them so we can find them again later. And that's where variables come into the picture.
So what even is a variable? Honestly, just think of it as a nickname for your data. Instead of having to remember or retype a piece of information over and over, you can just give it a memorable name and use that name instead.
The absolute best way to picture this is with a simple analogy. A variable is just a labeled box. That's it. You put the number 25 inside a box and you write user_age on the label. Now, anytime your program needs to know that age, it just has to look for the box labeled user_age. Simple as that.
Now, of course, you can't just name these boxes anything you want. There are a few simple rules to follow. They have to start with a letter or an underscore, not a number. They can't be one of Python's special reserved keywords. And remember, case matters. A box labeled age with a lowercase a is a totally different box than one labeled age with a capital A. All right, so we've got our data, and we've got it stored neatly in our labeled boxes. Now, this is where the real fun starts. We can finally tell the computer to actually do stuff with that data, using things called expressions and operators.
Now, there's a key difference here you gotta get. An expression is like a question that boils down to a single value. 2 plus 2 isn't a command. It's a question whose answer is 4. A statement, on the other hand, is a full-blown command. It's an instruction that tells the computer to do something, like user age equals 25, which says take the number 25 and put it in the box labeled user age.
So these symbols you see, these are basically our tools for doing math. We call them operators. You'll recognize the plus and minus for addition and subtraction. But take a look at the others. In Python, we use an asterisk for multiplication, a / for division, and a double asterisk for exponents, raising a number to a power.
Okay, but what happens when you chain a bunch of these together? Like, how does Python figure out what to do first? Well, it doesn't guess. It turns out it follows a very strict set of rules, an order of operations.
Yeah, it uses the exact same rule you probably got drilled into your head back in math class, PEMDAS. Anything in parentheses gets done first, no exceptions. Then it handles any exponents. After that, it does multiplication and division, just working its way from left to right. And dead last, it handles all the addition and subtraction, again from left to right. This strict order makes sure that your code is predictable and always gives the same answer. So far, our program has just been working away silently in the background, which is cool, but not super useful, right? For a program to be truly helpful, it needs a way to communicate with us. It needs to be able to show us information and get information from us.
So the main way a program talks to you is with the print function. A function is just a prepackaged command that does a specific job. For print, its job is simple. Whatever you put inside those parentheses, it'll display on the screen.
It's the most basic way to see what your code is actually doing. But talking is only half the conversation, right? How does a program listen? How do we get information from a person into our program while it's running? Well, for that, we have another handy tool, the input function. It's another one of these built-in commands. When your program gets to a line with input function, it literally just pauses and waits. It waits for you to type something on your keyboard and hit enter. And that's what makes a program interactive. Okay, listen up, because this is super important. This is a mistake everyone makes at first. The input function has no idea what you're going to type, so to play it safe, it treats everything you type as plain text, as a string. So even if you type the number 10, Python sees the text 10, not the number 10, and you can't do math with text. So how do we fix this? The solution is something called typecasting. We basically just tell Python, hey, I know this looks like text, but I want you to treat it like a number. We can use these other built-in functions, like int or float, to explicitly convert that input string into a number that we can actually use for our calculations. All right, let's take a step back. We have all our basic tools now, right? We've got data, we have variables to hold it, operators to work on it, and ways to communicate with our program. Now it's time to put all of these pieces together, to go from just an idea to a working solution by creating an algorithm. You hear this word algorithm, and it sounds super complicated, right? But it's not. It's really just a recipe, a clear step-by-step plan for getting something done. Imagine you had to explain how to buy groceries to a Martian who's never done it before. You couldn't just say, go get food. You'd have to break it down into these really simple, obvious steps. And that's all an algorithm is. All right, time for a little challenge. Let's put this into practice. Let's say our problem is this. We need a program that can calculate the area of any circle. How would we break that down into a recipe, into an algorithm? You think this might be complicated, but our recipe is actually super simple. It's just 3 steps. Step 1, we need to get the most important piece of info from the user, which is the radius. That's our input. Step 2, we need to do the math using the famous formula for a circle's area. That's our expression. And step 3, we show the user the final answer. That's our output. And check this out. Here's what that simple 3-step recipe looks like as actual Python code. Look at that first line. We use input to get the radius, and right away we use float to turn that text into a number. Then, in the second line, we make a new variable called area, and we use our multiplication and exponent operators to do the calculation. And finally, the third line, we just print the results. See? Every single tool we learned all working together in just 3 little lines of code. And just like that, we've gone from the tiny atoms of code all the way up to a real working program. You now have the fundamental toolkit, the basic building blocks for telling a computer what to do. The only question left is, what are you going to build? What problem will you solve first?